Okay, I've been playing this game 2048 like everyone else in the world, and so has my friend James Grime.
Hi.
So, in fact, we were talking backstage before a show.
Because that's what we do. That's the kind of world we live in.
We're close, personal showbiz friends.
That's right.
And we started talking about this game.
So we were both ignoring each other with our phones.
That's right. And I said,
swiping away.
Are you ignoring me for the same reason that I'm ignoring you?
Right.
And we started.
I wasn't.
You were ignoring me.
I had my own reasons.
Many different reasons to ignore me. But we started talking about, and there's loads of maths involved, so we thought we'd make a video.
Taking the internet by storm.
Exactly, yeah, absolutely.
2048. But we thought, well, it lends itself well to a touchscreen graphical interface.
That's right.
So I've made this.
You've made a sort of lo-fi version.
Yes.
So we can, in lieu of you actually playing the game, we'll show you how it works on this sort of cardboard cutout version.
Yeah, this is the home version of 2048. So we'll just quickly go through the rules.
Yeah, go on.
So you've got a 4x4 grid. You start by having two tiles which have the number 2 written on them. So two tiles, and they're in random cells.
Yeah.
And then you swipe up, down, left or right.
So I'm going to play this. So I'm going to swipe downwards like this. What's
so we go swipe.
Okay.
Like that. So everything falls down to the extreme edge.
Okay, great. And then a new tile appears.
A new tile appears, so let's generate a new tile in a random cell.
Okay. Now I'm going to swipe towards me. I'm going to swipe right.
Swipe.
And these two tiles have joined together now.
So these two 2s will join together. Their scores will add together. They'll create a new tile. So 2 2s make a 4. You actually score 4 points for making a 4.
So already the maths is very complex.
And you add and generate a new tile.
Another 2. Alright, so I'm going to swipe down again.
I'm going to swipe down, so swipe.
No, so these didn't combine.
So those don't combine because they're different values.
Okay. So if I wanted to... Oh, and now a new tile appears.
A new tile appears, you're quite right. So I've put that one in.
So I'm going to swipe to me again.
So swipe this way,
swipe.
Add a new tile. I think to make it a bit different, I'm going to add a 4 tile. Because it does turn out that 10% of the time they do generate a 4 tile for you. So let's throw that in.
Throw that in. Okay, so I'm going to swipe up.
You're going to swipe up?
Yeah, why not?
Swipe.
So those two 2s combined
again.
So we've got another 4 here.
This is swiped up as well. This is swiped up.
Okay. Now, what's the aim of the game?
And the aim of the game is to create the 2048 tile.
So, one of the questions we get all the time is, what's the best strategy for playing this game? You've completed this game.
Yeah, I've completed this game. I've got the 2048.
Yes.
Wow, have you completed the game?
Yes.
Hey!
Great, so we're
fantastic.
We're all
good, I'm glad. Have you got the 4096?
The
4096 tile, that's 2 to the power of 12.
No, because you get to 2048 and then you've completed the game.
Well, some people might give up when they reach the 2048 tile, but not people like me.
So you've carried on playing after...
I carried on playing, so you do get the option, you can carry on playing.
Okay, let me explain, if you haven't played the game, how it feels, right? You start playing the game and it feels very good because, you're like, this is fun, I've just made 128, now I'm going to make 256. And you get to 512 and like, this is easy, and you get to 1024, you're like, okay, right, 1 step to go, I'm close now, right?
Well, yeah. 1 step. Well, you're kind of halfway there.
Yeah, so it slowly dawns on you, actually, when you get to 1024, you've got to play that whole game again.
To make another 1024.
And then you can combine those finally to get to 2 minutes.
Yes.
And then, because what happens is you play it, it's fun, and then it becomes addictive, and then you realise it's hard, and you just play it for the rest of your life, you lose your job, your wife leaves you, you lose access to your kids. But then eventually you get 2048 and it's like being set free. It's like this wonderful moment where you can carry on with your life again. But now I'm told that James Grime has got 4098, so I've got to start playing again, unfortunately.
Don't feel too bad, because people have tweeted to me their scores, and I'm now aiming to get to the next tile, the 8000 tile.
So you've had a screen grab of someone.
Yeah.
And whether that's true or not, whether it was a fake, we'll get to later.
Okay. So my strategy is to get the largest tile, the largest numbered tile, into the bottom right corner, I guess any corner, and then to wedge it in there. So
right.
I would have my biggest tile there in the corner, and then from there I want sort of numbers kind of decreasing outwards from
right.
there. So I might have my 16s like this, and I'm kind of making a sort of like a triangle like that. And I want on the fringes, I want the smaller numbers, maybe some 4s or some 2s. I want to get that wedged in there though, so if I can complete this row and this column, and that doesn't get moved, it gets wedged in there, and then everything gets concentrated and focused on making the biggest tile possible in that corner.
Right, so you wouldn't, if there was something this was missing, you wouldn't swipe that way because you might end up with a 2 suddenly in there with all this over here. So you keep that, you do everything you can to keep that in there. This is interesting because I was looking at some AI that someone had programmed, a guy called Matt Overland. He built some AI to play this game.
Right.
And he encoded various strategies into the game. And this strategy is one of the ones that he encoded. He called it monochromicity or something like that.
No, he didn't.
No, what did he call it?
He called it monotonic.
Monotonic.
Or monoticity.
Monoticity, okay. But it's a maths thing. But basically what it means is you don't have...
This is how I speak. I speak maths fluently.
I don't at all. So you've got numbers either increasing or decreasing in all directions. Yeah. But never increasing and decreasing as you go along. So it's always going to go from high to low, from low to high, up and down and left and right.
So is it exactly the same as my strategy?
It is exactly the same. Yeah, exactly the same. But do you have any other strategies for playing this game?
Well, not really, apart from swiping and combining tiles and things like that.
Yeah, so this is the thing. If you're programming a computer to do AI, you need to tell it about those obvious stuff as well, like try and combine tiles. It's obvious, but you have to. And so one of the rules for this AI is that you want to try and keep as many of the squares free as you can.
Yeah.
Which means combining tiles. And the other one is try and get tiles of a similar value close together, which is basically the thing before combining tiles. So so if I swiped up, for example, that's good because I'd get these 8s together, and so that's a move that I could make, and that would be valued within this AI. And so these strategies are programmed in, but the way this strategy works is it's something called Minimax, which I will do in another video. But basically what it means is you assume that your opponent is going to make the worst moves for you, and you're going to make the best moves for you. And then you look at different options for what you can do and score them. And you score them, in this case, according to those different strategies.
So this is like 2 players.
Yeah.
Right, they're playing against each other.
Yeah, exactly.
You make a choice, they make a choice.
Yeah.
And it's like some sort of big tree diagram of choices.
Yeah.
And each decision gets a score.
Exactly.
Right.
But you can only go so deep, because with a tree diagram it gets more and more complex until you can't compute it anymore. So I don't know how far ahead you think in the game.
I can think a few moves ahead. I can start to plan and make a chain.
Yeah.
Yeah.
So it's the same with the AI. You analyse the different tree options, maybe 3 or 4 moves deep, and then you work out the best option. And it's based on those different criteria, but you give them different weightings. It's like, how important is it to have numbers decreasing and increasing, but not going up and down? How important is it to get numbers together? How important is it to keep the board clear?
So is the AI strategy the best strategy?
Well, I don't think it is, and the reason I don't think it is because of this Minimax thing. You're basically saying, I assume my opponent's going to make the worst move for me. But your opponent in this game, if you think about the moves you make a swipe move, and then your opponent adds a new tile.
Which is the computer, right.
Adds a tile randomly. But if you use Minimax, then you're going to work out the worst possible place for the tile to go. Or you're going to assume that your opponent will put it in the worst place. But that's not the case, it's random.
Yeah. So
really you should be doing something where you work out the average of what your opponent is likely to do. And then base your move on that. And I think that's the way humans play it. That's probably the way you play it.
Yeah, well, I try and sort of hope for the right tile in the right cell.
Yeah.
So I guess a AI doesn't cross its fingers.
Yeah, if you're going to play the game 10 times, you might as well cross your fingers because one time it's going to work, right? And so the strategy, I think, does end up being a bit different. There's a brilliant outcome of this, which is that someone looked at the AI that was built by this guy, Matt Overner, and he worked out a version of the game. He coded a version of the game where the computer puts the new tile in the worst possible place.
Yes.
It's a horrible game. The link is in the description.
You're welcome.
I don't know, this is one of those games where you tend to dream about it if you play it. You like Tetris, you ever have Tetris dreams? I've started having dreams about, tiles swiping around in 2048. This hard version of the game is like a nightmare.
Yeah, so Steve very kindly sent that to me.
What's the highest score you've got?
Not very much. I got to 128, which is pitiful. Because it's playing against you. The game is playing against you.
It's really horrible.
It's really horrible.
But actually, this isn't. So interestingly, there are loads of other versions of the game.
Yes, there are. So my favourite version of 2048 is the Doctor Who version. Have you played the Doctor Who version?
I haven't played the Doctor Who version. I've seen it on your phone, but I haven't played it.
The Doctor Who version, where each tile, instead of a number, is one of the doctors from Doctor Who. So you start with your Hartnells. 2 Hartnells make a Troughton.
Of course they do.
Of course they do. 2 Troughtons make a Pertwee.
So you're trying to get to...
And you're trying to get to Matt Smith, because Matt Smith is the 11th Doctor. This was perfectly accurate up to about October 2013. So you want to get to Matt Smith, the 11th Doctor, and that works because 2048, the goal in 2048 is 2 to the power 11. There are 11 steps in the game, and in the Doctor Who version there's 11 steps.
So the games are the same in some way?
So they're the same game. You've got... the tiles are exactly the same, you've just changed the labels.
Right.
So the gameplay is exactly the same, and that's called isomorphic. There are isomorphic games.
Okay.
The 2 to the power K tile is the Kth Doctor.
Okay, great. And so I've played the Doge version of the game. That's isomorphic as well. So you're just going through different Doge memes. Well, you're just combining the dogs.
So you just combine the same. You have to combine the same Doge meme.
Yeah.
To get to the next Doge
meme. And every time you do it, a word will appear saying such number or wow or whatever.
How do you know what order the Doge goes?
Well, that's how. That's why I think it's not isomorphic, because I know that 2s are 4, 2 4s rotate to 16 and so on, but I don't know that 2 Doges with their eyes moving equals a Doge with a pizza in the background.
But you do. But what you do combine the same type to make the next one in a sequence.
So if you know the sequence, it's isomorphic.
Yeah, that sounds isomorphic to me, as opposed to the Fibonacci version of 2048, where you have to join 2 adjacent numbers in the Fibonacci sequence.
Yeah.
Which is not isomorphic because you're not combining 2 tiles of like type.
Right, so it's a different game to play.
So the mechanics of the game underneath is fundamentally different.
What about Flappy Doge 2048?
No, that's not isomorphic.
But look at it go.
What is the maximum score, the best score that you can get?
So my best score so far has been 2048. That's the highest tile I've got.
Well, that's the thing. There are 2 games that you can play here.
Right.
So some people are just playing to get the 2048 tile.
Right.
But on the other hand, you can play to get the best score, because there's a score as well going along when you play the game. If you don't know, the way it works is if you combine two tiles together, like this, you combine them, they would merge, you would then create a 4 tile. And you get 4 points for that. So you get 4 points for creating a 4 tile. If I join 2 4 tiles together, I would create an 8 tile. I get 8 points for making the 8 tile.
So you get the number of points from the tile that you just made.
Yes.
And these are all added up together, and you've got a little running total.
You've got a little running total. So what's the best score you can get when you finish the game? And you finish the game is when you get the 2048.
Okay. Yeah.
So to explain the best score, there's actually a little formula for this, but to explain that, we'll keep it easy for now. We're going to just look at how to make the 16.
So, okay, we're going to look at what's the maximum score if you go up to 16.
Yeah.
All right.
So to create the 16 tile, what do I need to create the 16 tile?
2 8s.
Right, so I need 2 8s to make the 16. Now for each of the 8 tiles, what do you need?
2 4s.
So you need 2 4s to make each of the 8 tiles. Let's see if I can get those in. And to make each 4 tile, what would I need?
You need 2 2s for
Exactly.
4.
Exactly. I need a pair of 2s to make each 4 tiles. So I'm going to end up with lots. There you go. That's the other 4 I needed. And lots of 2s running off the edge of the board.
All right.
There we go. How about that? Lovely. So I need another pair of 2s.
So you've got 8 2s now.
Yeah. So what you made is a pyramid. So you start with. So you've got 8. 2 tiles on the bottom level.
Yeah.
To make four tiles, 2 8 tiles, and it all accumulates to make the 16 tile there at the apex of the pyramid.
And you get points for each one of these levels.
Yeah. So for each level, you actually get 16 points.
Yeah.
So for the top level here, you combine 2 8s to make the 16.
Yeah.
16 points.
Yeah.
For this level here, you combined 2 4s to make 8. 2 4s to make 8 again, and this scores you 16. This level scores you 16 points.
Yeah.
And it's the same here. All these 2s will combine to make a 4, a 4, a 4, and a 4, and these all add up to 16 points.
But you didn't make this bottom row.
Yeah, so these are created for free.
Right, so you don't get any points for these.
Yeah.
But you get points for these, and these.
Yeah, so each level of the pyramid is 16 points, so 3 levels, so it's 3 times 16. So it's 48 points to make the 16 tile. Altogether, you will score 48 points to make 16.
So how do we generalise that? Because we want to get to 2048.
Exactly. So 16 in maths world isn't just 16.
Which is where we are, by the way.
Which is where we are. 16 is actually 2 to the power 4.
Right.
And notice this pyramid has 4 levels on it,
Yeah.
all adding up to 16 apart from the bottom one.
So because it's 2 to the power 4, we've got 4 levels.
Yeah, so if you do it in general,
Yeah.
you have 2 to the power k, right, that would be a general tile of this type.
Yeah.
Then it would make a pyramid with k levels. The last one doesn't count, but each level would add up to 2 to the power k.
Okay.
So it would be k minus 1, lots of 2 to the power k. But we want to know the score for getting 2048.
Which is 2 to the...
Which is 2 to the power 11.
Okay.
So that would be a pyramid.
So K is 11.
Exactly. A pyramid with 11 rows. It'd be 10 lots of 2048.
11 minus 1 is 10.
See, I knew there was a reason I said that. 10 lots of 2048, so it's 20,480 is the score you would make for creating the 2048.
So that's the minimum score.
Well, not quite. It's the best score you could make if we were only generating 2s, but that's not the case, is it? Because 10% of the time you don't get 2s, you get 4 tiles. Which means 10% of the time I get a 4 tile, I can remove actually 20% of this row at the bottom.
Oh yeah.
Actually, these come for free here. That actually removes this from your score. So if you want to get the 2048 tile, it takes off about 400 points.
Okay.
So the best score, or a good score, a good game, should be about 20,000 points.
Well, you say best score, but when I got 2048, I had a load of other tiles on the board, so I had a 512 and all that stuff.
Yeah, this is where I disagree with how some people play this. I think the best score is your lowest winning score. I think the most efficient game is your best game. Because I think the most efficient game would be ending up with just one 2048 tile.
So this is a screen grab of James's best score, well, what James thinks is his best score, which is his lowest score with a 2048 tile on the board.
Yeah.
And you can see you've hardly got anything else there.
Yeah, so under 20,000, the cool kids get under 20,000. They're under 20,000 club.
Yeah.
Yeah. Now what is the maximum score, which is another question.
So we already know you've gone beyond 2048.
So you can go beyond, you can get the next tile, the 4,000 tile.
Okay.
You can get the 8,000 tile. In theory, We've looked at the game which has the hardest game. Yeah, that gives you the hardest tiles.
The AI that puts the tile in the worst
in the worst position, right? If you had a game that was really nice to you,
and just put the tile in the best place.
Put them in the best places, so it all worked out nicely. I reckon the best tile you could get, the highest achievable tile, would be 2 to the 16.
Right.
And then you would fill this board with 2 to the 15, 2 to the 14, 2 to the power 13, and 2 to the power 12, 2 to the power 11, 2, 4, 8 there, 2 to the power 10, 9, 8, 7, 6, 5, 4, 3, 2, 2 to the power 1, which is just 2, which we would end with, and we wouldn't be able to create any more tiles, because we need another 2 tile to merge.
Right.
And there's nothing here that merges anymore. That's about as much as you can do. And to make this, well, we know what each tile scores altogether. So the total score for this board, it's a big number, it's 1,835,012, which I reckon then must be the maximum score.
Is that with getting new 2s all the time?
That is assuming that it's just 2s that I'm generating. So if I generate 10% of those are 4s, if I get that, then I'd have to knock some points off for that. So I think the highest achievable, if everything's working your way, would be this one here, the 65,536.
We didn't say why this is the highest tile that you can get, but there is some reasoning behind that. Keep an eye on Seeing Banana YouTube channel to see James Grime giving an explanation of that. Now you looked at the highest score on the leaderboard.
Yes.
And the highest score was?
2 billion. No, a bit over.
Okay, so how have they done?
So which is a little bit higher than my 1 million and something. Because they hacked it.
Oh, okay.
Yeah, because the highest score on the leaderboards, you may notice, is 2 to the power 31 minus 1. Which is the highest achievable score you can make in a game programmed with 32 bits. Okay. But the worst scores are around about 100,000. And that is the score that I would predict you would get if you managed to get up to the 2 to the 13 tile, which is the 8,000 tile, which is my aim.
To get to this. And then someone sent you an image, a screen grab. And we were wondering whether it was fake or not.
And we can verify whether it's fake or not, or we have evidence whether it's fake or not, because the score should match what I predict it will be. We know what each tile on the scoreboard, or on this grid here, will score.
Yeah.
We can add all those scores together, and it agrees with the score that on the screenshot.
So either the guy that sent you the screenshot isn't cheating.
And isn't cheating. Fantastic, and I hate him.
Yeah. Or he's worked out all this maths as well.
He's done the same maths that I've just done.
And he's faked his score.
Yeah.
Okay. Let's give him the benefit of the doubt. And because you've got to the tile before that already.
I'm so close. I am so close. I've had the 4,000 tile with the 2,000 tile.
Yeah.
With 1,000 tile. I think I've got the 500 tile, and they're all lined up, and then I messed it up. And I'm so close, I'll get there.
So if you've been playing this game for a long time and you've completed it, there is still things you can do, like getting to 8,192 before James Grime gets there. You can also play the hard version of the game where it puts the tile in the worst possible place. And you can play the game that this was inspired by, which is a game called Threes, which is available on iPhone and Android. And you can also play Flappy Doge 2048. Don't bother playing that, it's rubbish. Anyway, thanks for watching. Subscribe or I will kill you.
You went too far. Too far.
I know. So I've been playing the game 2047.
What game?
Shut up.